You know the moment. Materials backed up, loaders are waiting, and your secondary plant is the bottleneck.
Yeah, and it's not just about slowing down production. That backup starts costing you in fuel, labor, and missed spec.
Exactly. And when you're dealing with recycled concrete, rebar, or inconsistent feed, most impactors just aren't built to keep things moving cleanly.
So today, we're breaking down a plant that's designed to solve that, keeping material flowing, reducing rework, and giving you more control over your end product.
This is the Lippmann 5165is-w. And if your operation depends on consistent secondary crushing without constant intervention, this is one to pay attention to.
Welcome to the Lippmann Academy CrushCast, built for decision makers in high-volume, aggregate, mining, and recycling operations. Nick and Jessica share practical insight for those selecting crushing equipment, managing quarry and plant production, and driving uptime and efficiency across material processing fleets. If your work is about moving rock, maximizing tons per hour, and running safer, more profitable sites, this is your show. This podcast uses AI-generated voice and presentation technologies with human oversight at every stage. All content is developed, reviewed, and approved by Lippmann. The information in these episodes is intended for educational and informational purposes only and does not constitute professional or business advice. Let's get started.
Welcome! This is the Lippmann Academy CrushCast. I'm your AI co-host, Jessica, and I'm joined, as always, by our resident technical expert and AI co-host, Nick. Nick, we're talking some serious horsepower today.
We really are, Jess. It's great to be here. And we are looking at a machine today that completely changes the calculus on how you handle that mechanical chaos you just described.
I love that. So let's set the mission for today. We are opening up the product information and specifications for the Lippmann 5165is-w.
Right, which is their versatile secondary portable impactor.
Yes. Now, Nick, when you and I were reviewing the specifications for this machine earlier, one word kept coming up over and over again: uptime.
Yeah, uptime is everything.
Because we hear a lot about capacity in this industry, right?
Yeah.
But if a machine is down for maintenance or, jammed with tramp iron, it doesn't matter how much it can theoretically crush, you aren't making any money.
Exactly. A parked crusher is just an expensive paperweight.
Totally. So today, I really want to explore how the sheer physical mass of this equipment, combined with its engineering, actually keeps a plant running. Where do we even start with this beast?
Well, I think we have to start right at the heart of the machine, Jess.
Yeah.
Like the crushing chamber itself. Because if you don't get the physics right in the chamber, the rest of the plant honestly just doesn't matter.
Okay, so into the belly of the beast.
Right. And the 5165 in the name actually refers to the physical dimensions of the rotor. You're looking at a 51-inch diameter and a 65-inch width.
Okay, that is a massive footprint for a spinning piece of steel. What kind of power is actually driving that?
So it's driven by a 300 horsepower motor, but the horsepower is really only half the story here. The rotor itself weighs 12,059 pounds.
Wait, 12,000 pounds? Just the rotor?
Just the rotor. Yeah.
That's insane.
It is, but that weight is absolutely not an accident. I mean, it's entirely by design. It all comes down to kinetic energy and the flywheel effect.
Okay, unpack that for me a little bit.
Sure. So if you have a lighter rotor and you drop a massive hard piece of concrete into the chamber, the rotor physically bogs down. It loses RPMs.
Oh, because it just doesn't have the momentum to carry it through the rock.
Exactly. And when the rotor slows down, the motor has to suddenly draw massive amounts of electrical amperage to try and get it back up to speed. That strains your entire electrical system and obviously halts your production.
It's like riding a bicycle uphill in the wrong gear.
That is a perfect way to put it. But when you have over 12,000 pounds spinning at speed, backed by that 300 horsepower, the moment of inertia is just incredible.
So it just doesn't care what you throw at it.
Right. When material drops into the massive 67-inch by 31-inch inlet, the rotor honestly doesn't care. It doesn't bog down at all. It just powers right through the rock, maintaining a consistent speed and, a consistent product output.
Okay, but let me challenge that a little bit, because crushing clean virgin rock is one thing. What happens when you're dealing with notoriously difficult recycle material?
Oh, yeah. The fun stuff.
Right, the really fun stuff. I'm talking about concrete loaded with steel rebar, wire mesh, or just uncrushable tramp iron. I always imagine that dropping a tangle of rebar into an impact crusher is like dropping a steel wrench into a kitchen blender.
That's a really vivid image.
Right. It doesn't matter how heavy the blender blades are, it just tangles up and destroys the machine. So how does this impactor avoid just tearing itself to pieces?
The wrench in the blender is actually a great analogy, but think about why the blender jams in the first place.
Because the metal gets caught.
Yeah, it jams because the wrench gets wedged between the spinning blade and the tight glass wall of the pitcher. It gets physically trapped. Lippmann engineered this machine specifically to avoid that trap by creating physical space.
Okay, how so?
Well, right under the crusher discharge, they've placed a massive 48-inch by 72-inch vibrating pan feeder.
So basically a vibrating steel table catching the material.
Exactly. But the key here is the open flow design. They engineered a really large, deliberate void between the bottom of the crusher and that pan feeder.
Oh, I see.
Yeah, because of that space, there is no tight pinch point for the twisted rebar or the wire mesh to get wedged into as it exits the chamber. It just drops freely onto the pan feeder.
That's incredibly smart.
It is. And that feeder utilizes rubber-mounted underliners to just absorb the brutal impact of that falling steel. And then it flows right out onto the belt.
Okay, so that makes total sense for the exit. You remove the pinch point. But what about inside the chamber?
You mean when it actually hits the rotor?
Yeah, exactly. When that piece of tramp iron actually makes contact with the blow bars on a 12,000-pound rotor spinning that fast, where does that force go?
That force is absorbed by a highly engineered curtain system. Inside the chamber, you have primary and secondary aprons, or curtains. The primary curtain is gravity-based.
Meaning it just hangs there.
Well, it relies on its own massive fabricated weight to hold its position and crush the rock. But yes, it hangs on a pivot. So if a piece of uncrushable steel hits it, the curtain actually gets knocked backward.
Oh, wow. So it gives way.
Exactly. It gives way just enough to let the iron pass, and then gravity just naturally pulls it right back into place.
So it yields to the steel instead of trying to fight it.
Yes. And then the secondary curtain takes a slightly different approach. It uses dual high-strength springs to maintain a tighter setting for finer reduction.
Okay, so that's for the smaller stuff.
Right. But again, those springs act as a relief mechanism. If tramp iron gets in there, the springs literally compress, the curtain backs off, the metal passes safely, and it just snaps right back to its original setting.
That is so clever.
They even include a hydraulic ram that physically takes the weight off the curtain so the operator can safely and easily add or remove shims to adjust those settings.
Wow. It really sounds like the machine is designed to absorb and deflect the chaos rather than just, trying to muscle through it and breaking something.
That's the exact design philosophy, yeah.
But Nick, absorbing all that abuse means wear and tear is just inevitable, right? Blow bars wear down. Curtains need adjusting.
Oh, absolutely. It's a high-wear environment.
So, if you're dealing with a 12,000-pound rotor and incredibly heavy steel components, how are operators supposed to maintain this safely? I mean, you can't just lift a solid steel blow bar out by hand. Doesn't that completely kill your uptime if you have to literally tear the machine apart?
This is exactly where the product specifications shift from just raw crushing power to intelligent maintenance. Lippmann understands that downtime for maintenance is the ultimate enemy.
Right.
So they actually made a plant-mounted 1-ton jib crane available as an option on this machine.
A built-in crane on the machine itself?
Yes, right there on the plant.
Wow. If you are an operator listening to this, you already know how huge that is. Without that, what's the alternative? You have to call a rental yard, wait for a crane to be delivered, pay a third-party operator.
Yep, and your entire plant just sits idle for a day or more, just so you can lift a single part.
You nailed the reality of it. The logistics alone are a complete nightmare.
They really are. With the plant-mounted jib crane, you handle the lifting right then and there, and honestly, it gets better.
Oh, do tell.
Our blow bars allow removal by pulling them straight up and out from the rotor, where some competitors must be pushed out through the side.
That takes hot work completely out of the equation.
It does. And from a safety perspective, they also include a heavy-duty rotor locking tool. I mean, when you have personnel working near a perfectly balanced 12,000-pound cylinder, the last thing you want is unexpected rotation.
Oh, for sure. That would be catastrophic.
Right. So the locking tool firmly secures the rotor in place while you work.
Okay, but how do you even know when it's time to use that crane? I would imagine opening the main hood just to inspect the blow bars is a whole process in itself.
It is, which is why you actually don't have to do it just to check the wear. Yeah, they designed a genius side inspection door. You basically loosen one single nut, open the side door, which, by the way, has integrated locking pins for safety, and you can immediately see your curtain adjustment settings and check your blow bar wear.
You can just look at them and know how.
Because Lippmann casts wear indicators directly into the sides of the blow bars, it is a physical notch cast right into the metal.
Oh, that is so smart.
Right. You open the door, look at the notch, and you know instantly if you have another wet of crushing or if it's time to flip the bars. No guesswork, no crawling inside with a tape measure.
That is the literal definition of working smarter.
Okay.
So the rock is crushed, the tramp iron is managed, the machine is well maintained.
Sounds like a good day at the quarry.
It does, but, pulverized concrete sitting under a pressure doesn't make anyone money. It has to be sorted and moved. How does the 5165 ISW handle the screening and conveying side of things?
Well, material is first fed onto the screen box.
A 6x20 triple deck. That is a massive amount of surface area.
It has to be, just to keep up with the 300 horsepower impactor. The screen uses a 3-shaft impulse mechanism located right in the center of the screen body.
What does that do?
Well, the eccentric counterweights inside generate this really aggressive oval stroke, which forces the material to stratify.
Okay, so separating it by size.
Exactly. Oversized material that is retained on the top deck of the screen goes to the crusher. Material that is retained on the second deck of the screen can either go to the crusher or drop to a cross conveyor. Material retained on the bottom deck is sent to the lower cross conveyor, and material that passes through all 3 decks of the screen is sent to the fines belt that exits via the rear of the plant. While you can't adjust operating angle, you can adjust the speed and amplitude to perfectly match whatever material you happen to be running that day.
Let me push back on the physical durability of that, though.
Sure, go for it.
Because you're taking a massive metal box, filling it with heavy rock, and just violently vibrating it all day, every day. Steel fatigue is a very real thing. Welds become brittle and they crack under that kind of constant vibration. How does a screen that size actually survive?
That is a very valid concern, Jess. And it's exactly why the construction specifications of this screen are so important. It features huck-bolted construction, with the welded decks huck-bolted to the side sheets.
Explain how a huck bolt works for those who might not know, because it's not just a standard nut and bolt, right?
Right, not at all. The aviation industry actually uses huck bolts for the exact same reason. See, a traditional weld is rigid.
And rigid things break when you vibrate them.
Exactly. When a rigid joint is subjected to violent, constant vibration, it eventually just cracks. A huck bolt uses a specialized collar that is permanently swaged, or basically crushed into the grooves of the bolt under immense pressure.
Oh, wow.
Yeah, it provides a massive permanent clamping force, but, and this is the key, it retains just enough microscopic flexibility to absorb the vibrational stress without fracturing. It exponentially increases the life of the screen box.
That's fascinating. And what about the actual screening media? I saw an option in the product information for a heavy-duty top deck.
Yes. So standard, you get side tension decks with oil bath lubricated bearings.
Which are better than grease bearings, I assume.
Way better. They run cooler and last much longer than standard grease bearings. But if you are feeding really large or highly abrasive primary discharge onto the screen, you can actually swap the standard crown top deck for a flat deck that's designed for bolt-in punch plates.
Oh, so it can handle much bigger impacts.
Exactly. It can accept up to a 10-inch feed size directly onto the screen without getting destroyed.
Okay, that leads me to the conveyors. Because to get the sorted material off the plant, the specs say there is a 60-inch wide underscreen fines conveyor and then dual 24-inch cross conveyors.
That's right.
Now, Nick, if there is one thing that drives operators completely crazy, it's conveyor drives.
Oh, don't I know it.
You have external motors, drive belts that stretch and slip, heavy metal safety guards that you have to unbolt every single time you need to tension a belt. I mean, it's a constant maintenance headache.
And that's exactly the headache Lippmann solved here. They completely eliminated the external drive belts and the belt guarding on those cross conveyors by utilizing motorized head pulleys.
Wait, I just want to make sure I'm hearing you right. The electric motor is physically built inside the spinning pulley roller itself?
Yes. The motor and the gearbox are hermetically sealed inside the steel shell of the pulley.
Let me challenge that for a second. If a standard external motor blows up, I unbolt it, swap it out, and I'm running again. If a motor sealed inside a pulley blows up, I have to replace the entire head pulley assembly. Doesn't that make repairs far more difficult?
It's a totally fair question, but the data actually shows it's the opposite.
Really? How so?
Well, external belts, sheaves, and exposed motors fail at a really high rate because they're constantly exposed to rock dust, rain, and debris. They require constant tensioning.
That's true.
But the motorized head pulley is sealed in an oil bath. It is completely impervious to the dust and water of a crushing site, so the failure rate is incredibly low.
Oh, I see. So it just doesn't break as often.
Exactly. Plus, you completely eliminate the external pinch points where an operator could get a hand caught, and you remove those bulky metal guards that just take up walkway space. And as a bonus, because it's a direct electrical drive, they are totally reversible with just the flip of a switch.
You can send your middle product left or right depending on your site layout. That is brilliant.
It really is.
Yeah.
And they didn't skimp on the belts themselves either. They use standard vulcanized belts, meaning the belts are spliced seamlessly using heat rather than using metal lacing that can tear out.
Oh, nice.
Yeah, and they have closely spaced idlers in the load zones to take the impact of falling rock, plus full-length skirting to keep the dust down and keep the rock actually on the belt.
Okay, so this is one impressive piece of equipment. Specifications are amazing on paper. But Nick, how does it compare with the competition?
When you pull up the data and look at competing rock crusher equipment manufacturers in this exact same class, the differences in raw dimensions, rotor weight, and basic material flow are frankly staggering.
Oh, I really want to dig into those numbers. We are going to dive straight into the competitive comparisons right after a quick break. Stay with us.
We'll be right back.
Every ton that goes through your plant starts at one place, the primary jaw. If it isn't flowing, nothing is. That's why Lippmann heavy-duty jaw dies are built to do more than just crush rock. Taller teeth, a more aggressive profile, and bigger gaps let fines pass through, keeping your chamber clear and your material moving. You get improved material flow, better product size out of the primary, and less slabby material heading to your cones and impactors. That means fewer blockages, less wear on the rest of your circuit, and more tons per hour where it counts. As the OEM, Lippmann designs these jaw dies to the same standards as our crushers, with lifting tools available for safer, faster changeouts and reduced downtime. Want lower cost per ton and long-term reliability from your primary crusher? Talk to your local dealer today and ask about Lippmann heavy-duty jaw profiles. Lippmann, legendary crushers, leading solutions.
Welcome back to the Lippmann Academy CrushCast. Now, let's rejoin Nick and Jessica as they continue the conversation.
Welcome back to the Lippmann Academy CrushCast, featuring the 5165 ISW. Before the break, Nick, you teased the competitive data. Let's talk about the other machines out there. What does the product information actually reveal when you put them side by side?
The numbers tell a very clear story, Jess. We won't name names, of course, but let's look at the specifications of some other rock crushers operating in this exact same secondary impactor class.
Okay, lay on me.
Let's start with the inlet size, the opening where the rock actually enters the crusher. While other machines might feature a 48-inch by 34-inch inlet, the Lippmann boasts a massive 67-inch by 31-inch inlet.
Wow. That is almost 20 inches wider. Functionally, why does that 19-inch difference matter to the guy who's actually loading the plant?
Because it eliminates bridging.
Bridging, like a logjam.
Exactly like a logjam. Bridging happens when multiple large pieces of concrete or rock try to enter the crusher at the exact same time and wedge against each other across the opening. Nothing goes in, and the operator has to physically stop the plant and carefully try to dislodge it.
That sounds incredibly frustrating.
It is. By widening that inlet by nearly 2 feet, Lippmann drastically changes the physical geometry. The material just spreads out and feeds evenly instead of bottlenecking at the opening.
So less bottlenecking means way more continuous feeding. What about the power comparisons?
This is where it gets really interesting. Where competing machines are running a 260 horsepower crusher with maybe an 11,000-pound rotor, the 5165 ISW comes standard with a 300 horsepower motor and the 12,059-pound rotor.
Oh, wow. So more power and more mass.
Yes. It all ties back to the kinetic energy we discussed earlier. A heavier rotor means much higher reduction ratios and far less strain on your electrical grid when you hit a hard spot in the feed.
Are there physical layout differences too? You know, things that are standard here but might be optional somewhere else?
Absolutely. According to the product information, the 5165 ISW includes several standard features that competing machines either lack entirely or make you pay a massive premium for.
Like what?
Well, Lippmann gives you dual cross conveyor standard, whereas others might only offer a single upper cross conveyor. Lippmann also offers an extended rear discharge conveyor.
Why is an extended rear discharge so important?
because it gives you the height and clearance needed to easily hit a secondary stacker feed point without having to build ramps out of dirt or dig holes for the tail section.
Oh, that makes setup so much easier.
Exactly, Jess. And of course, that plant-mounted jib crane we talked about is available as an option on the Lippmann, whereas you just won't find it on the other machines we compared.
It is so clear they engineered this specifically to keep moving. But Nick, that actually brings us to the final piece of the puzzle here. We have covered the brawn, the heavy iron, the huge screen, the wide belts. But realistically, running a plant with a massive vibrating screen, a pan feeder, a 300 horsepower impactor, and multiple conveyors sounds like a logistical and electrical nightmare.
It definitely can be if it's not designed right.
Right. So how does the operator actually manage all these systems without blowing breakers constantly? And how do they move this massive plant from job site to job site?
Well, it all comes down to user-friendly electronics and chassis design. The machine features a completely dust-tight electrical enclosure.
Good. Keep the rock dust out.
Essential. And inside, you have reliable, tactile, push-button controls for all the on-plant motors.
So if I'm the operator, am I manually switching on the discharge belt, then the screen, then the crusher in like a specific sequence every morning?
Yes, startup is fully manual and operator-controlled.
Got it.
That order still matters. If a feeder starts before the discharge conveyor is running, you can bury a dead belt in tons of rock and spend the next few hours shoveling it out by hand.
Ugh, the worst.
So the control approach here is operator-driven, tactile push-button control for the on-plant motors, with the operator starting each function in the right order.
That keeps the process operator-controlled. But starting a 300 horsepower electric motor must draw an unbelievable amount of power from the grid or the generator.
It does, which is exactly why they utilize a soft start for the main crusher drive. Instead of slamming the motor with full voltage instantly, which creates this massive inrush current that can incur huge electrical demand charges and honestly just burn out windings, the soft start ramps the voltage up slowly.
Oh, so it eases into it.
Right. You get that 12,000-pound rotor spinning safely and smoothly, completely protecting your electrical infrastructure.
That makes sense. And what about getting this massive plant set up on the dirt when you first arrive at a site?
The chassis is built for rapid deployment. It features 6 drop-down crib legs. If you've ever set up a plant, you know that cribbing, which is stacking heavy wooden blocks under the frame to level and support it, takes hours of back-breaking labor.
Yeah, lifting those blocks is no joke.
It's awful. These legs drop down hydraulically or manually to drastically reduce the amount of cribbing required. They also offer 36-inch stroke hydraulic run-on jacks to get the plant stable instantly. And for highway transport, you can even upgrade the running gear to massive 315/80R 22.5 tires, which handle rough quarry terrain much better than standard highway tires.
Stepping back and looking at the entirety of the 5165 ISW, from the physics of the rotor mass to the huck-bolted screen and operator-controlled startup, what is the big takeaway here?
The big takeaway, Jess, goes beyond replacing parts quickly. The plant is built around mechanical durability, maintenance access, and operator-controlled systems that support uptime.
So Nick, as we wrap this up, stepping back and looking at the 5165 ISW as a whole, it's more than just a secondary impactor. It's a system built to give operators better visibility, better control, and more consistent outcomes across the entire plant.
Exactly, Jess. From material flow to load management to maintenance access, everything here is designed to reduce guesswork and keep production moving. And that's really where Lippmann is headed. Solutions that help you make smarter decisions, protect uptime, and get more out of every hour on the job.
Thank you so much, Nick, for diving into these specifications with us today.
Anytime, Jess. It was a lot of fun.
Listener, if you want to see how this machine can completely transform your operations uptime, we have a few next steps for you. First, contact a dealer from our network found on our website, lippmanncrushers.com. Second, you can find the full product specs via the link in the show notes right below this audio. And finally, please download the episode, subscribe so you never miss an episode, and share this with your team. From both Nick and myself, thank you so much for tuning in to the Lippmann Academy CrushCast. Keep crushing it, and we will catch you next time.
Thanks for joining us on the Lippmann Academy CrushCast with Nick and Jessica. To explore more insights, catch new episodes, or learn how Lippmann is helping customers run smarter, safer, and more productive operations, visit LippmannCrushers.com and follow Lippmann Academy online. We appreciate you listening. See you next time.